It is said that God has created everything. He is the one who runs the whole universe. He also created those people who control this whole universe. And to understand those people, a revolution started from a small corner of the earth. Just like you came into existence, but no one can save them, no one can break them, not even God. Religion and science are closely related. Some people find science in religion and some find religion in science. And sometimes a thought arises that if our past is like a closed book, then why not? Consider this, you're witnessing the universe's beginning, but how did it all come into existence? For this, we have to look into the depths of the universe, and the farther we look into the universe, the further back in time we will see. This is a scientific concept. In my opinion, excessive detail is unnecessary, but still, if you want to know more, please let me know in the comment section. We will try to explain this in simple terms. Friends, this work was being done for us by the Hubble Space Telescope. It was observing in such a distant universe where the rays reach us after traveling for millions of years. In December 1995, Hubble captured a unique image in which even the smallest dot visible was a galaxy. There are countless galaxies in this universe, one bigger than the other. This image was named the Hubble Deep Field. This image is special because it shows us where our place is in the universe. Some of the farthest and oldest galaxies are visible here. Old light in old time. In the Hubble Deep Field, this galaxy was just a baby. This was the galaxy GNZ11, which means it was formed just 400 million years after the Big Bang. That means we were seeing the light from the universe just 13.3 to 13.4 billion years ago. After this, in 2004, Hubble captured another image, which was the Hubble Ultra Deep Field image, which at that time was showing us up to 13 billion years back. This ultra deep field was showing the universe as it was 400 to 800 million years after the Big Bang. In this image, there were about 10,000 galaxies, from which we got to know a lot. But at the same time, we also got to know more. Yes, in 2012, Hubble Nyström Deep Field image was released, which showed galaxies together as they were 13.2 billion years ago. Events that happened 450 million years after the Big Bang can be seen in this image. This image took us closer than ever before to the Big Bang, but we were still far from those mysteries. The things we see around us, how were they made in the first place? How was the first star, the first galaxy formed? Even before this, that first molecule, even before this, that first atom, finally how did all this come into existence? The universe is a mystery we wish to comprehend in the present and explore in the past. But when Hubble Space Telescope observes here, it doesn't seem so sensitive and not so precise. And the biggest limitation of the Hubble Space Telescope is that it is an optical telescope. When the universe was formed, there was no light in it, not even a single photon of light. So we can't know anything about that time and about the universe. To see into that dark age, we needed a very powerful telescope, which is even more powerful than Hubble. That's why the James Webb Space Telescope was designed, which was much bigger and also much farther from the Earth than the Hubble Space Telescope. Actually, this was a concept from which later on, the idea of making the next generation space telescope was born. At that time, there wasn't even enough technology to build such a telescope. But in these 25 years, many new technologies were invented just for this telescope, which in a way is a big achievement in itself. But after being made with so much effort and time, how special is this telescope actually? How does it do this? See, we've already learned a lot from the Hubble Space Telescope. From 13.3 to 13.4 billion years ago, it can observe light from that time. But we want to go even further back, all the way to 13.7 billion years ago. We want to see what the universe was like just a few hundred million years after the Big Bang. So, in this context, what is amazing is that the James Webb Space Telescope allows us to look back to the very beginning of the universe. This will show us the dark ages of the early universe. Through theory and observations, we are gradually learning more and more about the early universe. In the beginning, there was a point where all of space and time was contained in a singularity. Suddenly, there was a rapid expansion in that singularity, which brought space and time into existence, and with that expansion, the universe was formed. First, the hydrogen atom was formed, then molecules, and then these molecules combined to give birth to the first stars in this universe. According to theories and the Wilkinson microwave anisotropy probe, or Wilkinson microwave anisotropy probe, this happened about 180 million years later. At that time, the density of the universe was about 8,000 times greater than it is today. And what was formed first was about 30 to 1,000 times heavier than our sun and much more massive than our planets. But after a few lakh years, its fuel would have been completely exhausted, and the end of that star would also be quite violent, or it would have turned into a supernova, or it would have become a black hole. The stars would have become supernovas then. They produced heavy elements at their end and in the supernova, which later became part of the next generation of stars. The stars that became black holes at that time started pulling in gas and dominated the gravitational field. These are the same supergiant black holes that are present today at the center of every galaxy. So the James Webb Space Telescope will be able to observe the sources of those supernovas and gamma ray bursts, and we will be able to understand the story of the baby universe more clearly. In this way, the James Webb Space Telescope will also help us in discovering the first galaxies and the first star clusters. First light is also related to the birth of galaxies, and this telescope will work on them as well. It will help us in finding and understanding those first light objects. But to capture that first light, the James Webb Space Telescope will also have to rely on its imaging capabilities and precision. James Webb tells us that when the first galaxies were formed, there was a lot of hydrogen gas present there. So if we call them the first galaxies, were they all just primordial stars? Let me comment on first light for you. We will soon try to bring a video on this. How is galaxy made? Galaxy is a visible building block of our universe. Just like an island is formed, it happens due to the actions of sand. But we can't say whether it is made of sand or mud. Rather, it is said that a house is made of bricks. In the universe, the structure of galaxies is also similar to the structure of bricks. Theories and observations have given us a lot of information about the evolution of galaxies. We know that first smaller objects would have formed, which later combined to form larger objects. Then bigger, and then even bigger. This process is still going on in the universe today. Our galaxy is merging with a smaller galaxy nearby. Andromeda, the galaxy you reside in, is destined to collide and merge with another galaxy in the distant future. We have also seen a galaxy at the end of 1 billion years in the Big Bang. But even after this, there are still many questions and doubts. We still don't know how galaxies formed in the beginning. Which force shaped them? How did galaxies start forming? And how did elements from one galaxy reach another galaxy? Did black holes play any major role in all of this? Gravity or other physical laws have shaped today's universe. James Webb Space Telescope will also work on the theme of galaxies, and after the formation of galaxies, their formation and evolution will also be tried to be tracked. James Webb Space Telescope is so powerful that it can do this work easily. Now let's see how much scientific data we can actually get from this field using James Webb Space Telescope. The naming of stars and the prototype planetary system is being completed under the supervision of the International Astronomical Union. Whenever we look at the sky, we only see stars everywhere. Today, we can understand stars much better with their detailed observations and computer simulations. A few years ago, we didn't even know that these are generators of a kind of energy. And a few hundred years ago, we didn't even know that stars keep forming, that this is a part of their evolution. In fact, even now we don't fully understand it. How exactly these stars and dust clouds form, how they come together to create stars, this only happens in certain groups. If all of this could be explained by a single big star, then it would have been made that way. And along with them, how did planets finally form and how? How did asteroids become one and big too? When the gravity of these stars started to increase, the dust and massive planets began to come together. Our Jupiter planets also turned out to be quite big. James Webb Space Telescope's goal is to find out how stars are formed and how the conditions for life in the universe are created. How does a protostar become a protoplanetary system from a protostar? James Webb's highly sensitive imaging, spectroscopy, coronagraphy, and infrared sensitivity. This helps us a lot. We can learn a lot from these amazing discoveries. After this, there will be new discoveries with the James Webb Space Telescope about planetary systems and the origin of life, understanding the origin of our Earth, and studying the possibilities of supporting life on it. Science will play a major role in this. How, in a protoplanetary system, small objects formed, then how those gravitational influences or some forces caused those small objects to merge, how they joined together and grew bigger. The formation of planets happened. How did these planets come into the current orbit? How does one planet affect another? Every sign has a physical and chemical history. That's the story of that sign. For today's condition, we will have to look at every aspect of our surroundings closely. James Webb Space Telescope will focus on those places where life could possibly exist on other star systems. No, exoplanets are not easy to find. Mars will be imaged and spectroscopic characterization will be done. Additionally, distant celestial bodies like Jupiter, belt, dwarf planets, icy moons, and comets will be periodically observed. And we see that what we think is possible, but what you think is possible right now is the subscribe button. By the way, you'll get notified of every new video instantly. So what did you think of this one? If you liked it, then we know that you won't leave without liking and sharing it. If you have any questions, let us know in the comments. We're happy to help.